Hello everybody. Now we'll see about the definition of this parameters in detail. So as you see, this is a continuous time periodic signal. This is nothing but a sinusoidal waveform. A signal is actually a one which conveys information. So this sinusoidal waveform is not actually conveying any information, but it is a signal anyhow, right? So here we are interested in three parameters. The first one is amplitude, the second one is the time. From that you can calculate the frequency. Okay. So the second important parameter is frequency. But directly we cannot measure the frequency. So indirectly we are measuring it with the help of the time axis or time period. Then the third one is the phase. Phase is also directly you cannot measure it, but if you have two signals, then you can compare both, and the time difference, time delay between the both will give you the phase shift. Okay, now we'll see the parameters one by one. So what is meant by amplitude when you refer the signal? So amplitude is the peak value or the height of the signal, which is referred in y-axis. So this is your y-axis and this is your x-axis. Usually this is the function, okay, x of t, f of t, g of t, like that we measure. So here it is nothing but the amplitude of the voltage signal, or it can be a current signal or any other signal. Okay, so this measurement along this y-axis will give you the amplitude. So it is some a value along the positive y-axis. And what about this? Along the negative y-axis, it has another value that is minus a. So this peak to peak will usually give you the amplitude. Peak to peak means the whole height. It is a minus of minus a, so the total thing would be of 2a. In some cases the peak to peak value is measured, but usually we go with this positive half cycle or negative half cycle, like that only we'll take. So the amplitude of the signal is a here. So it is the maximum value the signal reaches. Okay. And what about the time period? We say that this particular thing represents the positive half cycle and this represents the negative half cycle. So when you go from this signal from 0 to positive peak and then 0 again coming along this and reaches the negative peak and then reaching the 0. So for this it will take some time period, isn't it? So from 0 to here, okay, reaching again the 0. So this time period is taken as capital T. So capital T is the time period. So after some time, again the same pattern gets repeated. See here. So this is your second time period, right? Second time the wave gets repeated. Again the wave gets repeated for the third time. So the same time period is taken for repeating a particular pattern. Here you have a pattern or a shape. So that shape or pattern gets repeated after some time. That is for after t. Then after 2t you get it repeated for the third time. After 3t it gets repeated for the fourth time. Like that you are getting it. Okay. So this is the time period t. From that time period we can measure the frequency of the signal. So frequency and time, they have this inverse relationship. So f is equal to 1 by t. Suppose this time period is equal to 1 second. 1 second is taken to finish this particular signal pattern, then we can measure the frequency as 1 by 1 second. So it is equal to 1 hertz. It is 1 hertz. That is the frequency. Suppose the signal takes suppose the signal takes zero point 0.5 seconds, okay, to finish one particular pattern. Finish the pattern, one pattern, okay, then the pattern gets repeated. Okay, so if the signal takes the time period of 0.5 seconds, then what is the frequency of this? Frequency is equal to 1 by zero point 0.5 seconds, isn't it? So it is 1 by 2. So that is equal to 2 hertz. Suppose the time period taken is 0 0.1 seconds to finish the first cycle. Then what is the frequency at that time? It is 1 by 0 0.1 seconds. So that is equal to 1 by 1 by 10. Then the frequency is 10 hertz. So you can measure directly along the x-axis the time period. From the time period, you can indirectly calculate the frequency. Actually, the frequency is the second important parameter. The first important parameter is the amplitude, but direct measurement is not possible. That's why we go for this time measurement along the time axis. Then you can convert it into frequency. Then the third parameter is phase. Phase is actually represented as theta or phi. So this is your first waveform, this pink color, and this blue is the second waveform. Then there is the phase shift of theta between these two. Okay, so what's the phase shift? Delay, that is theta. It is also used to, this parameter is also playing an important role. Okay, when you want to go for measuring the delays. So usually a complete signal will be represented something like this. Including all these three parameters, we can represent the signal like this. X of t is equal to A sine omega t plus phi. So it consists of all these things, right? See, here you have this amplitude, then here you have the time, the respective time along with this frequency is here given. That is the angular frequency, that omega is equal to 2 pi f. Okay, then this phi represents your phase shift or the delay. So this is the complete way of representing a signal. But actually the signal or the information will not be having a single signal like that. It is the combination of a number of sine wave and cosine wave. Then only you will be having the information. So this is a signal, even this is a signal axis along which you measure the time t. And here you will be measuring the signal or the function x of t. But actually it represents your the amplitude here. So your signal may be something like this. It can also be like this. Okay. But it gets repeated. Then it is a periodic signal. So this consists of a number of sine and cosine. Okay, but what is the time period here? The time period is, it starts from here if you want to measure and it ends here. This is your one time period from which you can calculate the frequency and all, because after this it gets, the same pattern gets repeated, right? So this is how we take it. So the maximum value here is, for a particular instant, it is A. After that you will be having some minima and maxima. So whenever you want to have the Fourier series analysis, so if you want to do the Fourier series analysis, you should have the signal that should be periodic. Then only it is possible. You should have the periodic signal. Okay, thank you. Hope you have understood this definition, and we'll see you in the next lecture. Thank you.